All right. Hi, everybody. Welcome to day 2 of our iOS 101 course. Today, we're going to dive into Swift. We're actually going to write some code and learn a little bit more about programming. But before we get into that, I want to kind of take care of a few housekeeping things and tell you a little bit more about Lambda School. So one thing is that in for this course or for the class today, we want to make sure you feel a little bit better prepared to actually submit your homework. I got a lot of feedback from people yesterday that they had trouble with actually submitting their Rainbow projects to their PMs. So just to be clear this time, when you finish the homework for today, take the folder that you created that has your project in it. So I'm actually going to share my screen, and then I can talk about it. So, for example, if I had made the flashlight app yesterday and I had it on my desktop, take that entire folder, right-click on it, and choose Compress to create a zip file, and then send this zip file to your PM. And you can do that by just dragging it into Slack. Open up a direct message to your PM, and then drag the flashlight.zip file onto, or whatever the file is called, onto the Slack window, and you can send it to them. And if you end up having any trouble with that, feel free to ask. But I just didn't want people to be quite as confused this time as they were last night. If you tried to use Git or GitHub to actually submit your project yesterday, that's something that we will do in the future. We will talk about Git during the full-time course, but it's a fairly deep topic, and it's got a bit of a learning curve, so I didn't think it was worth burdening you with in these first few days. Okay, another thing is I just wanted to talk to you a little bit about how Lambda School's full-time course works, if that's something you're interested in. I thought you might like to know a little bit more about it. So the iOS 101 course, as you know, is meant to be kind of a fun introduction to iOS, and it's completely free. But if you want to go further with that, and if you want to dig in and learn more and become prepared to actually be a professional iOS developer and go out and get a job, that's what our full-time course is designed to do. And the way the curriculum is structured, we actually cover 15 weeks of full-time instruction doing iOS. So that's 9 to 5 every day, Monday through Friday. We cover basically everything we think you need to know to go out and get a job. And it's a pretty long list. It's a pretty solid curriculum. And then after you finish those 15 weeks of iOS specific curriculum, you'll do 10 weeks of computer science curriculum. So that's not iOS specific. It's general computer science topics like data structures and algorithms, and how operating systems work, and some computer architecture stuff. You'll do some back-end programming, server-side programming with Python. It's a pretty rigorous 10 weeks, and it's actually one of the things that made me excited about coming to work at Lambda School, is that we teach that, which is something that I think is really cool, because it's interesting stuff, and it's also valuable when you're out in the job market trying to get a job. And then you finish up with 5 weeks of working on a capstone project. And this might actually be the coolest part of Lambda School. So you get to work on real world projects that are actually live and can get customers, and you're working with a senior engineer that has been in the industry and knows how real project development works. And so you get to apply all the skills you've learned over the past several months to build something real. But you're also getting to learn more about like development processes and how to work on a team and how to collaborate and all of that. So anyway, that's just kind of a quick overview of how our curriculum works. I'll continue to talk a little bit more about Lambda School's full-time offerings as we go. And with that, let's jump right in. Let's talk about Swift and Xcode some more. So we're actually today, we're going to use a feature of Xcode called Xcode Playgrounds, which is something that is actually relatively new, and it's something that I think is really cool, a really cool feature in Xcode, and it's specific to Swift. And so what is a playground in Xcode? Well, a playground is just a file. It's a document that you can type Swift code into. But the cool thing about a playground is that you can type your code in, and the playground will immediately run it and sort of show you what your code did, show you whether it worked or not, and what its output was. And so these are a really great way, playgrounds are a really great way to explore and learn Swift. But even as an experienced developer, I use playgrounds pretty often to try out new ideas or learn a framework or a technology that I don't already know. Or even sometimes if I'm designing a user interface and I just sort of want to iterate on it quickly and try different ideas and see how things look, I'll use them for that. So we're going to start out playing with playgrounds today. I'm going to share my screen again and show you that if you start up Xcode and you get this welcome to Xcode window, the first option over here is actually get started with a playground. So you can click that to create a new playground. The other way to do this is to go File, New Playground. Do one of those. Let's create a new playground, and I want everybody to follow along. So choose File, New Playground, and this sheet will come up. And let's talk about this for a second. This is sort of like when you created a new project yesterday. You had several options, several templates basically for your different playgrounds. There's iOS, tvOS, and macOS. You can't actually create a watchOS playground, but otherwise it looks similar. And there are a few templates under each section. We could create a blank iOS playground, and that would work fine. But I'm actually going to say that today we should create a blank macOS playground. And the reason for that is that macOS playgrounds tend to perform faster. They just take less computing resources. And I know some of you are not on brand new, really fast Macs, so this will probably make life easier for us. Swift is the same whether you use a macOS playground or an iOS playground. It's exactly the same language, so that doesn't really matter. It's not going to change anything else we do. So go ahead and make sure you've selected macOS and then the blank template and click Next. And then choose a name for your playground. I'm going to call mine Variables, and you can just put it wherever you want. I'm going to put it on my desktop, but you put it wherever makes sense for you. I already have one, so I'll replace it. And this is what a playground looks like. It's just a document where you can start typing code. So let's talk about a few of the aspects of this window. There are basically three major areas here. There's the main area, which is where you actually can type code. You could call that the editor. And then over on the right is this sidebar. This actually shows you what your playground is doing as you type. So it's kind of continuously checking to see if you've changed something, and then it will compile and run your Swift code. And each line of code, if it does something, if it produces some kind of output, it will show you what that output was on this line. It's out of sync just because I accidentally hit return. This should be on the same line as this. And then the third area that's important is what's called the console. So down here at the bottom is a little strip, and you can actually drag that up and see this area at the bottom. The other way to do that is to click this button right here. It's near the top right corner of the window that says hide or show the debug area. If you click that, you can toggle the console. So what is the console? Well, the console is just an area where your program can print, or in other words, display text. So if you want to have your program output some text, we're going to talk in just a minute about how you do that, but this is where it will show up. And it can just be helpful for seeing what your program is doing. The console also exists in Xcode when you're working on an iOS project, and we'll see that a little bit later today too. Okay, so I'm going to delete this, and we're going to start with a fresh playground. We don't need the import statement either. So you can delete that, or actually you can import Foundation if you'd like. We don't need all of Cocoa, which is kind of everything you need to do Mac app development. And we're going to talk about something, our very first feature of Swift that we're going to talk about is something called a constant. So what is a constant? Well, basically programming is all about teaching a computer what to do to solve a problem that you want to solve. But it turns out that almost every real app or every real program has to deal with data of some sort. And in fact, every program does. And that data can take many, many different forms. I mean, you can think of text data for any app that deals with text. And there's images and audio files and video and now we've got virtual reality and augmented reality kinds of files, and a calculator deals with numbers, but at some fundamental level, all of that stuff is data. So programs have to deal with data, and that means that you, when you're writing your program, have to deal with data. And so it's really helpful to be able to give a name to an individual piece of information or an individual piece of data. And so one of the ways we can do that is with what's called a constant. And the syntax for a constant is you start with let, and then you give a name to the value. So I could call my value something like number. And then, so I've created a constant called number, but I need to give it a value. Right now it's just a name and there's no value. So I'm going to say equals, and then the value I want this number to have, I'm going to say 42. So now number is a constant with a value of 42. So what's the point of giving this a name? Well, it means we can refer to it later on in our program to do things with it. And one of the things we can do with a constant is we can print it out to the console. Oh, my playground has crashed. Let's see if we can get that running again. So to print this to the console, I'm going to use something called a print statement. And the way a print statement works is you first type print, and then a parenthesis, and then whatever you want to print. So in this case, I want to print the value of number. And then you stop by, or you finish it off by closing the parentheses. So this statement, this print statement says, take the value of number and print it. But what does print mean? It doesn't mean send it to your printer and put it on paper. That's not what it means. What it means is print it out to the console, show it on the console, which is this area down here. And of course, my playground's acting up on me, so I may have to restart it. Yeah, let me try restarting it. Sorry about this, guys. All right, there we go. And you can see that on this line, because the number was created with a value of 42, we see a 42 over here in this sidebar area. And then the print statement causes that to actually be output to the console here. Okay, so that's all fine and good. We've created a constant, we've given it a name, we've given it a value, and then we've done something with it. We've printed it. That's probably not blowing your mind, but it turns out that this is the building block of things that we do all the time. There's a variation on a constant. There's a variation on naming a value that I also want to talk about, and that is a variable. If you've done any programming in another language, you know what a variable is. If you're brand new to all of this, then you don't. But it's one of those things that is common to almost every programming language that exists, and so you'll become very familiar with it as you get more experience programming. So what does a variable look like? Well, a variable starts with var, var, instead of let, but then otherwise it's the same. You give it a name, so I'll call this one other number, and you give it a value. I'm going to say 10. And of course, I can use it just like I used the number here. I can print it out. And so if I do that, well, this is being finicky again. It prints out 10, 42, and then 10 because we printed the first number and the other number. So what's the difference between these two? Well, the difference is that a constant is just that. It's constant. It can't be changed again. After you give a constant a value, you can't change that value. Number will always be 42 now. Whereas a variable is something you can change, you can modify. So if I decide that I want other number to be a different value now, I can just say other number equals 5. And if I print it again, you'll see that it now prints 25. And so that's what a variable is. What happens if I try that with my first number, my constant? If I say number equals, some other number, 33, what will happen? It'll say cannot assign to value number is a let constant. And that just means you can't give number a new value because it's a constant and you created it using let. So why would we want two different things? Why would we want a let constant or a var variable? What's the point of having two different options, and when would we use one versus the other? Looks like you've got a couple people are saying that they've got a playground problem. Unfortunately, playgrounds in Xcode can sometimes be a bit finicky. If you're having a problem where it's kind of seeming to not update, or if it's giving you an error you think you fixed, probably the quickest thing to do is just to quit Xcode by selecting Xcode. and then quit Xcode in the menu, and then just restart it and open your playground again. I wish I had a better recommendation for you, but unfortunately, that's what I know how to do right now. Apple has said that in the next version of Xcode, Xcode 10, they're making a lot of really nice big improvements to playgrounds, and I hope that's true. All right, so back to this. Why do we have var versus let? Well, it turns out that if you write enough programs in other languages that don't have constants, this idea of a constant is not unique to Swift, but it's not as common. Every programming language has variables, but not every programming language has constants. If you write a bunch of programs in a language that doesn't use constants, you'll find out that there are actually a fair number of common bugs that occur because you accidentally changed the value of a variable without meaning to, and then that had side effects that you didn't want. So this allows you to say explicitly, I want this to have a value, but I never want it to change. And so it makes your code safer, basically. It allows the compiler to, instead of just kind of letting you do whatever you want, even if it causes a bug, it allows you to tell the compiler, hey, I never want to change this, and if I accidentally try to change it, I want you to warn me because that was a mistake. So it's safer. But of course, there are other times when you have a value that you want to be able to change. So there's still a real reason to use a variable. So which should you use? Well, my rule of thumb is always use let. If you're creating a new named value, just use let, make it a constant. And then only change it to a variable if you definitely know you need to change it. So your kind of go-to thing, your muscle memory should be to use let. And then you should kind of reserve var for those specific situations when you know you need to change a value. If you get in the habit of using var all the time, you're kind of short-circuiting that safety that constants can provide. So default to the safe option, which is a constant, and then only use variable if it really makes sense. Restarting didn't work for me. I'd say get with your PM and see if you can get any help there. I wouldn't worry a whole lot about it, because this is kind of like follow along and try things, and just so everyone is aware, the homework today will not be in Playgrounds. It will be an Xcode project for iOS like we did yesterday, just using some of these same concepts. So I don't want you to freak out if Playgrounds are being kind of finicky for you. Okay, so that's sort of constants and variables in a nutshell, and you're going to use these in every bit of Swift you write from now on. You're going to become very familiar with them. But there's another aspect to these that I think is important to know, and that is that in Swift, every value has a type. So what does that mean? Well, that means that the Swift compiler, the computer, needs to know not just that there is a value, but what kind of value is that? Is it a number? Is it text? Is it Boolean, which means is it true or false? Is it an image? Is it something else? Does it represent a person? And we call that what is this? We call that a type. So what do you think the type of the number 42 is? Does anybody have any guesses? Put them in Slack if you've got a guess. What do you think the type of 42 is? What is this thing? Okay, so I'm really impressed. You guys are sharp. You're saying it's an int or an integer, and you're all right. Somebody said the answer to life, the universe, and everything, and of course that is why I used 42. But it's an int, and so some of you may remember from math what an integer is, but a lot of you probably don't. It's certainly not a word I use in everyday conversation. An integer is also called a whole number. It's just a number that does not have a decimal after it. So it's the numbers that when you count, you use 1, 2, 3, 4, etc. That's an int. Well, how do we know that this is an int? We know that it's an int because it doesn't have a decimal after it, but we never said that it's an int, right? We never explicitly told the computer, hey, this is an int. It just figured it out. And we can actually see that it figured that out by holding down the Option key on your keyboard and then clicking on number. It will say let number :int, meaning number is a constant called number, and its type is int, which is short for integer. So the way that it determined that number is an integer is using something called type inference. So type inference is a feature of Swift that means that the compiler is able to infer or figure out what type something should be just from context, just from kind of what it looks like. But sometimes type inference, doesn't work. Sometimes the compiler can't quite figure out what something is, or we want to tweak it and say, well, yeah, I know this looks like an integer, but I actually want it to be a different type. So we can also, if we want to, explicitly tell the compiler what type a constant or variable is. And the way you do that is by putting a colon after the name, and then a space, and then the name of the type. So in this case, an int, which means integer. So we can do this too. Here, instead of using type inference to just have the compiler figure out what number is, we tell it explicitly. So this is called a type annotation, an explicit type annotation. Somebody asked about semicolons. Semicolons are optional in Swift. You can put them at the end of the line if you want, but you shouldn't do that because you'll look like a weird Swift programmer if you do that. Basically, you don't use them in Swift. So this is an explicit type annotation. More often than not, you'll leave this off when you're just creating a variable. Type inference is really good, and it works really well, and it's nice to not have to type that extra thing. And it reads a little nicer, right? This kind of putting this :int sort of clutters things up. But it's nice to know that it's available. So one type is int, but let's talk about some other types. Another common type that you'll use a lot for numbers is non-integers, integers with a decimal point. So let's say we want to do 2.5. Well, we can do that. And with 2.5, 2.5 is not an integer because it's not a whole number. It's instead what we call a float, in a floating point number in programming. And I remember first learning about floating point numbers and thinking, well, why is it called floating point? Why not just call it decimal number or fractional number or something like that? In what way is the point, the decimal point, floating? And what floating point really, what the float in floating point means is that this decimal can have an arbitrary number. It can have any number of digits before it or after it. It can float around. You can have a float with its decimal place all the way at the end like that, or you can have a float with its decimal place like that with a lot of digits after. That's what the float part means. But I agree that it's kind of confusing. Just remember that when you hear the word floating point, it just means, or float, it just means a decimal number, a number with a decimal place. So if we option click on decimal number, we see that it says it's a double. But wait a minute, I just said it was a float. It turns out that there are actually two kinds of floating point numbers in Swift. There are floats and doubles. So what's the difference between the two? Well, a float takes up a little bit less memory, but it also means that you can't have quite as much precision and you can't represent numbers that are quite as big. So really what it means is that in the computer's memory, a float takes up a fixed amount of memory. And what that means is that it can have only a certain maximum number of digits. Well, if you think about writing a number out, say we can only have a number with 4 digits. That's the most we could have. Well, that means we could represent 9,999, which is a really big number, or we could represent 0.0001, which is a really small number. But we're kind of limited. We can't do anything that has, more zeros before it than that. So our precision is limited. And we can't do anything bigger than 999 because we don't have enough. We can only do 4 digits. Floating point numbers work the same way. They can have way more than 4 digits. They can be quite large and quite precise, but still there is a limitation there. So what's the difference between a float and a double? Well, a double takes up twice as much memory, which means it can effectively have twice as many digits, which means it can represent numbers that are larger, maximum numbers that are larger. It also means it can represent numbers that are much smaller than a float or more precise than a float. So why would you use a float if you could use a double? Well, that's a great question. And most of the time you will actually use a double, not a float, when you have a floating point number. And that's because modern computers, even modern phones, have lots of memory. In comparison to the amount of memory your phone has, a floating point number takes up uh, very little space. So that's why when you write a decimal number, the compiler assumes you want to use a double because you probably don't care that it's going to take up twice as much space. If we do float, we want it to actually be a float, we can explicitly annotate the type and say, I want this to be a float, not a double. And you can see now that it is a float because we've explicitly told it we want it to be one. So I want to answer questions that Joe Rudd said in Swift, is there not const, just let and var? Right. The const keyword is something in C and C, languages that sort of derived that from C. It's not something you use in Swift. Instead, you use let if you want a constant. JC asked, what about when you're dealing with money, float or double? That's actually an excellent question. For technical reasons that we don't have time to get into depth on today, you actually shouldn't store money amounts using a floating point number. Rather, the typical best practice for that is to store them using integers, but not dollar amounts. So you might do cents or tenths of a cent or even hundredths of a cent. It turns out that floating point math on a computer is not perfectly accurate. Why does print output the number with /n instead of just the number? So if I print number, I think my playground's broken again, so I'm going to restart it. You'll see a /n here, \n. We're actually going to talk about that in a lesson that we do entirely on strings, but this is shorthand for a new line, a return character. So meaning print 42 and then kind of move the cursor down to the next line. And you can actually see that here. If you play around, you can see that there's actually a return after 42 and then another line after it. So that's what that's showing, but it's not a big deal. Okay, so what are the other types that we can use? Well, there's kind of an infinite number. I mean, there are lots and lots of types built into Swift, and you can actually create your own types, as we'll see later. But for today, I want to talk about these few types. I want to talk about int, uint, float, double, bool, and string. An int is an integer. A uint is an unsigned integer. So what does that mean? This is short for unsigned integer. An integer is a whole number, but it can also be negative. So -1 is also an integer. Uint, on the other hand, unsigned means it doesn't have a sign, a plus or a minus in front of it. And really what that means in practice is that it's always positive. So uint cannot be negative. It can't go below 0. The question quickly becomes, why would you use an int? Why would you use a uint if you could just use an int? Because ints can be negative or positive. Well, there are really two reasons for that. One is that occasionally you want to write code that enforces the idea that a certain value should never be negative. But actually, probably the most common reason why people use uint instead of int is because uint can represent a number that is twice as big as the maximum number that an integer can represent, because it basically uses one of its digits, one of its spaces in memory to store a plus or minus. An int does that. Whereas uint can use that space for an extra digit, so it can be much bigger. Yeah, 0, both an int and a uint can be 0. But yes, they can both be 0. Okay, so we already talked a lot about float and double. That's a number with a decimal point. What about bool? Well, bool, which is short for Boolean, is just a value that can only be either true or false. It can't be anything else. So we can say, is Swift cool equals true. This is now a bool. And if we make this a variable and then try to change it to, 42, it won't work. It will say you can't assign a value of type int, which is 42 as an int, to a variable that is of type bool, because it doesn't make any sense. If this is a Boolean, it can only be true or false. So those get used a lot. Turns out that very often in programming, you want something that's either true or false. You want to check to see if something's true or see if something's false, etc. And then the last one that we're not going to go into a lot of depth on, but I just want to briefly talk about, is a string. So what is a string? Well, a string is text. It's letters and words. And the way you create a string is using quotes. So I could create a variable that holds my name, a constant, sorry, that holds my name. And I just put my name in quotes. Anytime Swift sees double quotes like this, it says, oh, that's a string. And so if I option click on this, you'll see it says it's a string. So strings get used a lot too, of course. I can print my name to the console. And man, my playgrounds are being so flaky today. It's frustrating. Sorry, guys. And you'll see that it prints out. So that's a string. The question was double or single quotes. Swift only uses double quotes. So there are some programming languages where you can use either double or single quotes, and they, in various programming languages, they mean slightly different things. Swift only uses double quotes. Okay, so if you've gotten this far, you're probably thinking, well, creating all these values is great, but what do I do with them? I want to kind of run through a challenge with everyone to just give you a taste of why you might care about this kind of stuff. Imagine that you're just starting to work on an app that's going to keep track of people, like a contacts manager, or maybe even a social networking app. And to test it out for the first time, you're going to put some information about yourself into it. But you need variables to store things, to store all the stuff that you want to keep track of about yourself. So go ahead and create some variables or constants or variables for various aspects of yourself. Things like your name, your favorite color, maybe your hometown, and your age. And I want you to think about whether each thing should be a constant or a variable. Constants are things that will never change. Variables are things that might change in the course of running the program. And of course, this is just an exercise, so you don't need to think too deeply about it. I just want to give you a chance to practice typing this stuff and using it. And to start with, let's not put type annotations on. So instead, we'll just let the compiler use its own type inference to figure out what each type should be. So I'll give you about 5 minutes to work on that. Somebody said, can you compare across integer types the same way you can compare a float, double, and int? I'm not exactly sure I know the context of that question, Jeffrey, but we are going to talk about arithmetic operators today. So how you can add, subtract, multiply, and divide, and we'll see a little bit about how double, float, int, and uint interact if you try to add them together or something like that. We'll talk about comparisons and logical operators a little later, tomorrow actually. Oh, so you are talking about arithmetic, logical comparison. That's a really great question, and I want to just double check really quick that I actually know what I'm talking about before I tell you something wrong. Okay, so Swift is quite strict about types, and there are quite a number of operators that will not work on two numbers of a different type, even if you think, oh, they probably should. Like, for example, you can't add a float to an int without going out of your way to tell the compiler that you really know what you're doing. But comparison actually will work for uint and int. It will not work for comparing an integer to a float. So, but Eli's got a good point. This kind of question is exactly the kind of thing you can use a playground to figure out. It's one of the reasons playgrounds are great. If you're used to a language like C or JavaScript or Python or any number of other less strictly typed languages, you may end up getting a little bit frustrated that Swift yells at you when you're trying to do stuff with different types of numbers. And I don't know, it can be annoying, but that's part of what Swift is doing to try to keep you safe and make sure you don't write code that doesn't actually do what you meant for it to do. Okay, so I hope you've had a chance now to create some variables for yourself. I'm going to do that, or some constants for yourself. By the way, you'll probably often hear me say variable, and I use that to mean both variable and constant. That's because Variables are, variable is the term that is used in every programming language, whereas constants are less common. But you even hear people say a constant variable, which is actually a contradiction, but what they really mean when they say that is a let. So anyway, I'm going to create my name, a variable for my name. I'm going to create constant for my favorite color, but maybe this should actually be a variable because I change my favorite color sometimes. I'm going to create a variable for my favorite food because that changes sometimes too. Oh, by the way, I'll show you something kind of cool. Swift can actually have emojis in it. So I can actually make my favorite food the pizza emoji. And I'm going to say my hometown is Salt Lake City. I could move, but my hometown will always be Salt Lake City. It's where I grew up. Yeah, so somebody asked, shouldn't name be a var? And you're right. Of course, people can and do change their name for any number of reasons. So that's a fair point. This was, of course, just an exercise, and I just wanted a mix of both. All right, so now I want everybody to print all these. So just add some print statements for each item of your about me. Sean asked, how did you get the emoji to pop up? There's lots of ways to do that, but the easiest way is Control Command Space. It's the keyboard shortcut to show the emoji viewer. But yeah, anyway, Control Command Space. It's also in the edit menu somewhere. Can't remember because I never do it that way, but oh, emoji and symbols right here. And that's not an Xcode specific thing. That actually works in any Mac app. It's a good thing to know. Yeah, so we're not going to talk about the whole UTF thing today, and I think it's actually often okay to use emoji in strings. You could actually make, you can actually use emoji for variable names too, but I don't think that's a good idea. Do this, it will work. But don't do that. It's going to make your code hard to read. It's, for various technical reasons, likely to cause problems for people using different text editors, etc. It's cool that Swift can do it, and maybe in 20 years we'll all be writing all of our code using emojis, but right now it's probably not such a great idea. Okay, so I hope you've all had time to create some constants and variables describing you, and then print them out. And with any luck, if your playground is behaving, unlike mine tonight, you'll see those actually get printed out in the console. Mine has been very finicky and unreliable. And it all worked just like you'd think. So let's move on to the next thing that you can do with values. We're going to talk about arithmetic operators. So what does arithmetic operator mean? Well, it just means the things that you can do with numbers. And you're all used to these from math. We're just talking about adding, subtracting, multiplying, and dividing. And we're going to talk about one other arithmetic operator that you're maybe a little less familiar with. But let's start with kind of the simple ones. So let's say I'm going to start with, I just want to multiply two numbers together. Well, I can actually just do that. I'm going to create a constant called answer, and I want it to be 7 times 6. I just do 7 star 6. So star is the arithmetic operator for times or multiply. And of course, this should be exactly what you expect 7 times 6 to be if it runs. And anybody know what 7 times 6 is? 42. This is frustrating, guys. I'm sorry that I keep having to restart this. All right. Yeah, when the result's not starting, or when the result's not showing up, or this is like showing an old error that I've already fixed, I'm actually just restarting Xcode. Quitting Xcode itself and then restarting it and reopening my playground. Okay, so we can multiply numbers, we can add them, we can divide them. Well, we can subtract them, I guess I should say. And we can divide them. Let's see, what would we call dividing? I don't know, I can't think of the word for that right now. Okay, so these all make sense, right? 7 times 6 is 42, 2 plus 3 is 5, 10 minus 3 is 7, and 5 divided by 2 is 2. Well, wait a second, that's actually not quite true, right? 5 divided by 2 is 2.5. So this gets into a topic called integer division. And integer division is not unique to Swift. It's something that's common to most programming languages, essentially everyone I've ever used. And integer division is like the division you learned in elementary school, where you came up with an answer and a remainder instead of a fraction. And so the way that works is 2 goes into 5 twice with a remainder of 1. Well, Swift just throws away the remainder and gives you the answer without the remainder. So the answer is 2. We can see this again. If we do 7 divided by 2, the answer is 3, because 2 goes into 7 3 times with a remainder of 1. That's how integer division works. Now, we could do this again and instead say 7.0 divided by 2.0. And because we use decimal points, the compiler will say, oh, that looks like a floating point number. And it will assume that these are doubles. And then instead of using integer division, it will use regular floating point division. And it will give us the number we maybe expected, which was 3.5. It can't do that here because it turns out this is actually something you commonly want when you're programming, is to be able to do integer division. And the answer needs to be an integer. So the way the thing to know is that if you actually want a decimal number, you need to make sure that the two things you're dividing are floats or doubles. Another way you can do that is actually explicitly say you want the answer to be a double, and then it will say, oh, okay, they want the answer to be a double, so I'll use regular floating point division. So just know that. Just realize that integer division is like the division you learned in elementary school, where it's an answer and then there's a remainder that just gets thrown away. But what if we want that remainder? So what if I want to know what the remainder of 7 divided by 2 is? I can think through it in my head, and of course it's 1. But you want to be able to have the computer come up with that answer. So you can do that using what's called the modulo operator. The modulo operator is a percent symbol. So 7% 2 means divide 7 by 2 and give me the remainder instead of the answer of the division. And my playground has crashed again. So quit. John, I'll answer your question in just a minute about 7 divided by 4.0. So this gives us 7 modulo 2, is how we would pronounce this, is 1. It's the remainder of 7 divided by 2. Well, that's actually kind of cool because it also helps us know if a number is even. So what if we want to know if a number is even? We'll say let number equals 75. Is 75 even or odd? Well, of course, we can look at it and say it's odd, but what if we want to test that in our program? We could say is even equals 75 modulo 2 greater than 0. 75 modulo 2 is greater than 0. Sorry, equals 0. That would be is odd. Do that instead. If we want to know if it was odd, we can say 75 modulo 2 greater than 0, meaning if the remainder of this division is greater than 0, then it wasn't even. 2 didn't go into it evenly. There was some left over, so it's odd. Otherwise, if we make this even now, 74 is even. Well, I don't think it actually updated. Oh, sorry. I'm not paying attention to my own stuff. So I was using 75 right there instead of the actual variable. So if we check to see if that's greater than 0, and if it's even, will not be greater than 0 because there was no remainder, meaning 2 went into it evenly, and this will be false. It's not odd. So that's one thing that the modulo operator is really useful for, is determining whether a given number is evenly divisible by another number. Okay, so that's arithmetic operators, and I want you to try writing a little program in your playground. Create constants for the ages of a few of your relatives, your siblings, your parents, you and your cousins, whoever you want to do that you know their ages. If you don't have any family or friends, then make some people up and calculate the average of all of their ages. And so in case you don't remember, the way you calculate an average is you add all of them up and then you divide that by the total number of people that there were. And when you've done that, assign the average that you come up with to a new constant called average age. So you'll calculate all that. You'll assign that to an average age, and then I want you to print average age to your console. And I'm going to give you, let's see, let's take 10 minutes to do this. Actually, let's call it 9 minutes so that we have 5 minutes left. So spend 9 minutes writing. I'll write out some instructions here. Create constants with the ages of several family members. Calculate their average age. Assign that to a constant called average age, and then print average age to the console. While you're working on that, John, I'll talk about what if you try to do x equals 7 divided by 4.0. You should try it, of course. That's the best way to figure things out, is to try. And what you should get, if your playground runs, mine probably won't. Well, mine won't run, so let me restart it again. But it will figure out that because one of the numbers is a double, you probably meant to use floating point division, so it will give you a floating point answer, a double answer, and x will be a double. Now that actually only works if you use constants here. If these were variables, like let a equals 7 and let b equals 4.0, where this is, because the way this works is it says, oh, that's a double. This one could be an int, but it could also be a double. It could just be a floating point number where you left the decimal place off, because that's a valid shorthand for a number with only 0 after the decimal place. I'll just treat this as if it were a double. If instead I say a divided by b, it won't work. And the reason this won't work is because it already saw that a was an integer, assumed that it was an integer. Same with b, it was a double. And then by the time we get to this point, well, a is already an integer, and you can't divide an integer by a double or a floating point number, because it just doesn't know how to do that. It doesn't know whether it should give you an integer result or a double result. So the way to fix that is to convert a to a double, and the way you can do that is by saying double and then parentheses around the a. And that will work, and you get the answer you expected again. So this is where Swift gets kind of tricky and is really strict about your types, and it won't let you, it won't let you kind of mix types in the same expression. So this is a good thing to learn, is that if you want to convert a number that's one type to a different type, you put the type you want it to be and then parentheses around the number. All right, 4 more minutes, and then we'll move on. If you have questions or you're stuck on something, please remember that you can and should reach out to your PMs. The best thing about an opportunity like the class that we're doing is that you get help instead of just following tutorials or reading a book and not having anyone to ask when you get stuck. So you're very much encouraged to ask questions and get help when you need it. Uh, Min, I'm sorry if I'm pronouncing your name wrong, but I think your problem is just that Playgrounds is being finicky on you. So you should just quit Xcode and restart it, and then open your Playground again. Because a quick look through your code looks right to me. It looks like that should be working. You should be getting the right answer. It's just being finicky. And CJ, yours doesn't quite work. So you're getting the answer of 181, which you would have some very long-lived family members if their average age were 181. And the reason that's happening is because of order of operations, which is also called precedence. And this actually goes back to math that you probably learned at some point in math class in school, where your let average equals grandmother plus mom plus wife plus daughter 1 plus daughter 2 divided by 5. Kind of looks right, but what it's actually doing is, because division comes before addition in the order of operations, it's first dividing daughter two's age by 5 and then adding that result to all the other ages. And instead, you want to add all of the ages up and then divide that entire total by 5. So the way you can fix that is to put parentheses around all the addition before the divide, like a plus b 5, like that. These are different types. Um, Oh, and you need a name constant. By the way, playgrounds are cool. They don't actually make you make everything a variable. If you just want to add some numbers together, you can do that until they die on you. But anyway, put parentheses around, grandmother plus mom plus wife plus daughter 1 plus daughter 2, and that should fix it. Jonathan, I have an iMac Pro. I have 3 or 4 Apple IIs, and they do have better, more reliable basic REPLs than this. But yes, playgrounds are finicky. Just restart Xcode. One thing is, as I said at the beginning, the Mac, if you make a Mac OS playground, it tends to be faster than an iOS playground. And the reason for that is because iOS playgrounds actually run everything through the simulator, which itself takes time to start up and run. Okay, time's up. I hope you all did okay with that. I'll do it quickly. Let's say let brother equals 25, let mom equals 60, let dad equals 65, whatever. I can say let average age equals brother, mom plus dad divided by 3, which is how many relatives I listed, and then just print out their average age. And my playground died again. I'm going to file bug reports with Apple because this is just absurd. It hasn't always been this lousy. And so their average age is 50. Okay. No, you don't need to upload screenshots. When we're kind of just working along during the lesson and I'm giving you challenges, we don't expect you to submit any of that stuff. It's just kind of for your own personal, learning and exploration and practice. It's only the homework that you should submit. All right. And for those of you worried about Playgrounds crashing, you're not going to actually work as an iOS developer in Playgrounds. They're meant to be a tool and one that's not working so great today. And you'll be happy to know that we're not going to use them for the homework assignment. So I want to go through a couple things with you. First, let's talk about the homework assignment. And as we talk about that, I want to show you something that I think I should have covered a little bit better yesterday. And that is that we actually have a website where you can see all of your curriculum for this course. It has been linked a few times, but if you go to learn.lambdaschool.com, we have what we call Training Kit, and this is just our curriculum website. Up at the very top, you'll see iOS development. If you click on the little arrow, you'll get a drop down, and you can select syllabus, which is just sort of an outline. And we're of course doing the iOS Dev 101 class, so each heading is a day. Yesterday we did Intro to iOS, and these are kind of all the things we learned. Today we're doing Intro to Swift, and these are sort of all the things we talked about. Tomorrow we'll talk about conditionals and optionals, and we'll talk about all of these things. So this is just a good outline to kind of give you an idea of what you're seeing. But if you want to dig in a little deeper, select the curriculum link, and then over here in the sidebar, each row is actually a week or 2 weeks worth of content. So iOS Dev 101 is the course you're doing now. And then here's each day of that course. We're doing Intro to Swift today. So click on that and you get a bunch more detail. And at the top, you'll see project. This is actually your homework assignment for the day. So you can click on the link and it will take you to GitHub where you can see the instructions for the project and all of that, including a bonus question for today's. So that's where you can find it. If you're watching this video later, you're not watching the live stream, or you just forget, go to learn.lambdaschool.com, click on iOS development, then curriculum, and then iOS Dev 101. Find the lesson that you're doing. We're doing Intro to Swift, and then you'll click on that and you can find the project right at the top. The other thing you'll see here is that we actually have written text for each of these subjects, where if you want to review or you want to, you learn well by reading, we actually go through each of the things that we're talking about here. It's not meant to be the primary way you learn. The primary way you learn is meant to be these live stream lectures. CJ said the live stream stopped. I wonder if it stopped for everyone. Okay. CJ, I think it's just you, so catch up with the video later. That was worrying. So anyway, read through this if you want some review. You could also read through it before our lecture if you wanted to kind of prepare ahead of time. This is sort of got all the stuff we're going to cover. And then the last thing I want to talk about, just briefly, you've already seen me use this several times today and probably yesterday, is comments. So comments in code, every programming language I've ever used supports comments. Comments are just little notes that you can write to yourself or to the programmer that comes after you to explain what your code is doing. Because we try to write our code so that it's as easy to understand as possible, but sometimes, no matter how hard you try to do that, certain things are going to be confusing, and you want to leave yourself a note so you can remember what you were thinking or why you were doing that later. And so to create a comment, there are two ways to create a comment in Swift. If you want to create a comment on the same line as some code, you'll put it after that code, and you just use 2 forward slashes, and then anything we type after this is a comment. And because it's a comment, the compiler will see these 2 slashes and say, oh, okay, everything after this is a comment, and I'm going to ignore it. It just doesn't even process it at all. If you want a comment that spans multiple lines, you can do that like I did above up here, where you do /* to start the comment. And everything after that will be a comment. And then as soon as you're done with your comment, you do */ to end it, and then you can write code again. So those are the 2 kinds of comments. You'll see this in code that you read, but you should also get used to writing them. They're a good way to, I think as you're learning, a really good thing to do is, if you're writing new code and you're trying to learn it and everything's still unfamiliar to you, leave comments to yourself, because even just the act of writing them and forcing yourself to explain what you're doing can help you learn. But it will also give you a reference to look back on and remember, oh, here's why I did this. Here's what this means. Here's what I was thinking when I did this. They're a great thing. And so Jeffrey, Swift actually doesn't use pragma marks the way Objective-C did. The equivalent is actually a special comment, and we'll talk about that at some other point, but it's not really useful in a playground. Okay, so that's the lesson for today. Get going on your I should actually describe the project before I just let you loose, because I showed you the link, but we didn't actually go through it. So let's go to it and look at it. You're going to build an app that's actually somewhat similar to what we did yesterday, in that it will just have a single button and it will just do one thing, but call it About Me. And select Swift as the development language. Make sure you do that. Again, it should still be there since you selected it last time, but I just want to make sure nobody ends up with Objective-C. I want you to add one button to the app. Call that button Introduce Me. And when you tap that button, what should happen is you print out a bunch of information about yourself. And to do that, again, create constants or variables for your name, your hometown, your favorite color and food, and anything else you think somebody would be interested to know. And again, think about which ones should be variables and should be constants. And then use print statements to print each constant or variable to the console. And then go ahead and run the app and click the button and make sure everything works. And in Xcode, when you've got an actual project open, I don't have a copy of this homework to open, but I'll just open. Well, that's somebody's rainbow. I don't want to do that. I'll open. Thought I had something handy, but of course I don't. I'll just create a new project. That's what I'll do. I'm just going to create a quick new project. And so if I do a print statement, this right here will happen right when the app starts up. If I just say hello in a print statement and then I run my app, what you'll find is that there is a console in Xcode. You see it the same way you see it in a playground. You click this button right here, and it's down at the bottom, and it's the part on the right. If that's not showing, you can click this button here that says hide the console. It'll say show the console. And anyway, that's where the console lives. So click this and then click that. I think it should show up automatically for all of you if you've used a print statement. It's important to note, though, that this is not in your app. It's in Xcode. So what if you want the person using your app to actually see something? Well, we're going to cover that in a lot of depth later as time goes on. But I thought for those of you that finish quickly or find this easy, a nice challenge would be to figure out how to output the text in the app instead of just in the console. So your bonus problem is add a text view to your app. You can find this in the object library. Create an outlet from your view controller to the text view. Some of you have already figured out how to do this for stuff you did on the project yesterday, but you'll need an outlet to access the text view from your IB action. And then in your IB action, instead of using print statements, add your introduction text to the text view. And I've given you a couple hints. You should look up string interpolation in Swift. That will help you figure out how to turn variables into text if you're not using print. And if you want to put text in a text view, you'll use textview.text equals string. These are purposely somewhat vague hints because I want you to stretch yourself. Sometimes the best way to learn is to struggle a little bit and try to figure something out. But as always, if you are having a hard time or you're running into problems or you need help, you should ask your PMs for help. That's what they're there for. I'm going to sign off, but if you've got questions, put them in Slack and I will do my best to answer. So Min said, so our final app should click the button that shows About Me. Yes, you should have a button called Introduce Me, or Introduce Me. And when you click that, it should print out all the information about you. And this is partly to give you practice creating apps and adding buttons like we did yesterday, so you don't forget everything that you've learned so far. All right, thanks again for joining me, and I look forward to seeing what you come up with for your homework. See you tomorrow.